Hello everyone, my name is Tyler Nelson, and today I'm going to be showing you how to do the Calculus BC 2009 FRQ question number 6. And so the question starts off by saying the Maclaurin series for e to the x is e to the x equals 1 plus x squared over 2 plus x cubed over 6, and then it gives us the general term x to the n over n factorial. The continuous function f is defined by f of x equals e to the x minus 1 squared minus 1, all of that over x minus 1 squared, for x is not equal to 1 and f of 1 equals 1. The function f has derivatives of all orders at x equals 1. And for part A, it asks us to write the first four non-zero terms and the general term of the Taylor series for e to the x minus 1 squared about x equals 1. And for that, all we need to do is we need to take the Maclaurin series for e to the x, which is, as given to us, 1 plus x squared over 2 plus x cubed over 6, and then x to the n factorial. Take that, and then you need to, whenever you see x, you just need to put in x minus 1 squared. So then we get 1 plus x minus 1 squared plus x minus 1 to the fourth over 2 plus x minus 1 to the sixth over 6, and then and then we get the general term x minus 1 squared, all of that to the nth. It can alternatively be written as x minus 1 to the 2n, all of that over n factorial. And then that's our answer. And then for part B, it asks us to use the Taylor series found in part A to write the first four non-zero terms and the general term of the Taylor series for f about x equals 1. And for that, since f of x equals the series that we just found, e to the x minus 1 squared, minus 1 over x minus 1 squared, we can just take this series, minus 1, get rid of that, and then divide the entire thing by x minus 1 squared. And so if we do that, then we get minus 1, get rid of that, and then this is just going to be 1 plus x minus 1 squared over 2 plus x minus 1 to the fourth over 6 plus x minus 1 to the sixth, we over 24 ... And then if we look at this, we can discern that the general term of this is just x minus 1 to the 2n over n plus 1 factorial. That's an x. So then that was B. And then for C, it says use the ratio test to find the interval of convergence for the Taylor series found in part B. And for that, it's really simple, ratio test. You just do limit as n goes to infinity of absolute value of, you plug in the general term, but instead you put n plus 1, so then it would be 2n plus 2, all of that over n plus 2 factorial, take all that divided by x minus 1 to 2n over n plus 1 factorial. And if we do that, then we can see that this is x minus 1 to the 2n plus 2, and this is x minus 1 to the 2n, so then the 2n's cancel out, and then we just get x minus 1 to the 2, or just x minus 1 squared. Oh, forgot to write limit Never forget to do that. Just pretend that's there. And after that we have this. It's divided by the denominator is divided by something, so this is actually in the numerator, and the numerator is divided by something, so that means that's in the denominator, and then we get the fraction n plus 1 factorial over n plus 2 factorial. And since this is always just going to be n plus 2 factorial is just going to be n plus 1 factorial times n plus 2, that equals x minus 1 squared times 1 over n plus 2. Again, forgot the limit. And then if we plug in infinity to that, regardless of what x value it's going to be, this is going to be 0. So that means that the interval of convergence is negative infinity to infinity, because it works for every x value. And then for D, it asks us to use the Taylor series for f about x equals 1 to determine whether the graph of f has any points of inflection. And for that, we just need to look at this and then take the double derivative of that, because the double derivative shows us if it has any points of inflection. So that goes to 0. That times 2 cancels out the denominator, and then turns that to a 1. And if you continue out the process, use it for the entire Taylor series, or for at least the first 4 terms, then you get this. And then if we look at that, we can discern that the general term is going to be, that's term 2, so that means that's going to be 2n times 2n minus 1, all of that over n plus 1 factorial. And then all of that times x minus 1 to the 2n minus 2. And then, so, since all of these terms are positive, and they're always going to be positive, for n is always going to be greater than 1, the slope is always going to be, not the slope, f double prime is always going to be positive. And since that means that it's never going to be 0, it doesn't have any points of inflection, because that's a point of inflection is when the double derivative equals 0. And that's that. That's how you solve 2009 FRQ question 6.